All right, so we just learned some things about rhombuses, so let's see if we can apply it and answer some questions. So quadrilateral ABCD is a rhombus. So if you're told that it's a rhombus, that means everything we just learned applied. All four sides are congruent. It's also a parallelogram. It's under that umbrella of parallelogram, so all your parallelogram properties apply. And also, we know that the angles are perpendicular bisectors of each other and that they will bisect opposite angles. So, we're told that we've got that 53-degree angle. We know that that's 53, and we know that these are also 53-degree angles over there. We could fill in more. Let's just kind of see what they're actually asking us. That doesn't even look like a 53. 53, there we go. So given that we have a rhombus, what is the measure of angle ADE? So we're going to have D as the vertex. We go ADE back to D. So this is the angle right here that we are trying to figure out. Well, remember the diagonals of a rhombus are perpendicular, so we can work with a right triangle. We've got two angles in our right triangle. Because this was 53 up here, that gave us the 53 degrees inside this triangle. And we know that these three angles should add up to 180. So all we have to do is take 180, subtract out the 90-degree angle, and subtract out the 53-degree angle, and we will be left with the angle measure that we need, 37 degrees. So let's just make a note. This is the property we use. In a rhombus, the angles are bisected by the diagonals. Probably should have written that down first. So because the angles are bisected, we were given this 53 degrees. Using this property, that's how we knew that this was 53. And this is the 53 degrees that we used to find the angle we were looking for. All right, part B, quadrilateral GHJK is a rhombus. So again, we know we're dealing with a rhombus. What is segment GH? So GH is right here. Well, we know that all four sides are congruent in a rhombus. We know that this side, HJ, is 3x plus 1. So if we can figure out the value of x, we can plug it in here, and then we know that GH will be the same, will have the same measure. So what can we do to write an equation and solve for x? Well, one thing we learned about a rhombus is that the diagonals are bisected. That helps us because we have this diagonal right here. If this diagonal got bisected, that means that this half is congruent to this half, and there's our equation right there. We can say that 2x plus 3 is equal to 4x minus 7. The diagonal got bisected, so it splits it into two congruent halves, and we can write an equation from that. So solving for x, we get our x's together first, so we can subtract 2x from both sides. Carry down our 3 equals 4x minus 2x is 2x. Carry down our minus 7. Now let's solve for x. We'll add 7 to both sides. So 10 is equal to 2x, and then if we divide both sides by 2, we're getting x equal to 5. They didn't ask us what x was, they did ask us what GH was, so we had to do that legwork in order to answer the question. But we know that GH is congruent to HJ because all four sides in a rhombus are congruent. Well, HJ is 3x plus 1. They told us that that is 3x plus 1, and now we know the value of x. So we're just going to say 3 times 5 plus 1. 3 times 5 is 15. 15 plus 1 is 16. And because GH and HJ are congruent, we know that GH will have the same length as HJ, so GH is equal to 16.